All right, guys, we're going to take a look at end behavior in this video real quick. So a couple reminders. If you have a positive leading coefficient, your end behavior is going to end up to the right. So this whole row here, I'm thinking, okay, positive leading coefficient ends up to the right, versus a negative leading coefficient is going to end down to the right. So two graphs that end down to the right. Now, if we know the degree, even degrees go the same direction. So if the graph starts or ends up to the right, it's going to start up to the left. Okay? Odd degree, if the graph starts up to the right, or ends up to the right, it's going to start down to the left. With the negative leading coefficient, so again, even degrees go the same direction. So it's going to look like this. And odd degrees go opposite directions. It's going to look like that. Okay, so let's use that now and look at a couple examples. We have one that's in standard form and one that's in factored form here. So for the problem that's in standard form, the degree is just the biggest exponent. Okay, so negative leading coefficient, odd degree, so we know it ends down to the right. And because it's an odd degree, it must start up to the left here for this one. Now that's in standard form. In factored form, we don't look at just the largest exponent. Instead, we're going to have to take the sum of our multiplicities, in other words, the exponents on x, or on each factor. Okay, so we have x to the first, we have x to the first, and we have x to the second. That tells us that our degree is 4. So we have an even degree, and we have a positive leading coefficient. So positive leading coefficient means it ends up to the right. Even degree, it's going to go the same direction as it starts. Okay? Now I should mention right here that if this x was not here, so in front it's just a 2, there's no x in front. We would not count the 2 to the first as part of the degree. It's only the x's. So that, again, if that x is not here, this is now x to the first, x to the second. Our degree would be 3, and that means that the left portion of the graph, it still has a positive leading coefficient, still ends up to the right, but it's going to start down and to the left like that. Now let's use this to look at an inequality here. Okay, and so let's say we have our polynomial in factored form, and we're going to figure out when it's positive, when it's greater than 0. So we can do this by graphing, or we can do this by making a number line or a sign chart. We're going to use a number line to do this one here. So to solve this, I'm going to take each factor and I'm going to set it equal to 0 and solve for x. So if I take negative 2x and set it equal to 0, I would divide by negative 2. All right, next we're going to set x plus 3 equal to 0 to get negative 3. And you can ignore this square, just set x minus 1 equal to 0 and get x equals positive 1. Now, I'm going to take these 3 zeros, I'm going to place them on a number line from least to greatest, so the negative number would go first, then the 0, then the positive. And for each of these, I'm going to look at their multiplicity. So the multiplicity is the exponent on the x. If we have an even multiplicity, that 0 is going to bounce off the x-axis. And if we have an odd multiplicity, it's going to cross through the x-axis. So let's look. 0 came from x to the first. That's an odd multiplicity of 1. So at 0, the graph is going to cross or change sign. At negative 3, it came from this factor, also an odd multiplicity of 1. And so at negative 3, again, the graph is going to cross or change sign. And then lastly, at x equals 1, that came from this factor that had a multiplicity of 2. So because that's an even multiplicity, this is going to bounce. Now to fill out this sign chart, there's a few different ways we could go about it. I like to just start with the leading coefficient. So because this is negative here, the graph is going to end down to the right. And so that tells me this last section here is going to be negative because the graph is moving down to the right. Now, If I got the total degree here, the total degree is 4. So if the graph ends down to the right, it's going to start the same way. And now I have the option of just, okay, anytime it is going to change signs, I'm going to switch from negative to positive. Here it's going to change signs, so it's going to go from positive to negative. And the last one we already knew was going to bounce, so it does not change signs, negative to negative. Okay, once we have this set up, the original question was asking when it's positive, when it's greater than 0. The only place that occurs is right in here, in this interval, not including the endpoints. And so we would write that as negative 3 to 0. I'm going to use interval notation, negative 3 to 0, but not including either negative 3 or 0. Now, again, this question was already factored here. You might be given a question where you are asked to factor, and so there will be some like that in the practice where you're going to have to factor first and then go through this process. All right. We also have the option of checking some of these if you're not confident with your signs. What I could do is take a value in this interval, for example, like negative 1, and I could replace all of the x's with negative 1, and then use order of operations to add or subtract, use the exponent, then multiply, and make sure I do in fact get a positive number for the value in between those 2 points. All right, so we'll go ahead and stop here. You guys can do your practice now, and then we'll go over that again on Monday in class.